Three crime scenes, 3,000 years apart. Babylon, the jungles of Central America, a river valley in India. None of these people ever met. None of them read each other's work. But all three tried to solve the exact same impossible problem. How do you write down nothing? This is the story of the number that took humans longer to invent than the wheel, longer than writing, longer than cities, the number 0. The trail to find out who invented it first is stranger than you think, and messier. Stick around. The final answer isn't what most textbooks tell you. To understand why 0 was so hard to invent, you need to see what came before it. Ancient civilizations could count. That part was easy. 1 sheep, 2 sheep, 10 sheep, no problem. But counting nothing is a completely different kind of thinking. Around 4,000 years ago, Sumerian scribes hit this wall first. They wrote numbers in columns, the same way we write 10 versus 100. But without a symbol for an empty column, their numbers got dangerously confusing. 61 could look identical to 601. Imagine your bank account mixing those two up. So the Sumerians did something clever. They left a gap, a blank space where a number should be. It worked, sort of. But a blank space is easy to miss. A missed gap could cost an entire harvest, or start a war over a tax record. Here's the deeper problem, though. Marking an empty column isn't the same as understanding nothing. Try to picture 0 sheep standing in a field. You can't. There's nothing there to see. Egyptian scribes ran into the same wall and never solved it. Chinese mathematicians used a blank space too, for over 1,000 years. Whole civilizations sat right next to this problem and simply walked past it. That's the wall every one of our suspects had to climb. Not a notation problem, a thinking problem. One civilization is about to build the first real clue, and it happens somewhere you use every single day, without realizing it. Fast forward to the 3rd century BCE, ancient Babylon, the Sumerians' mathematical descendants. The Babylonians used a number system based on 60, not 10. That system is still alive today. Every time you check a clock, 60 seconds, 60 minutes, 360 degrees in a circle. But Babylonian scribes ran into the same gap problem their ancestors had. So they invented something new. 2 small wedge marks pressed into wet clay. Not a blank space anymore. An actual symbol. This was the first recorded 0-like mark in human history. But here's the catch. It wasn't really 0 the way you think of it. It couldn't be added. It couldn't be subtracted. It held no value of its own. It was a placeholder, a parking spot for nothing, not a number. And it only appeared in the middle of other numbers, never at the end, never alone. A scribe could write the equivalent of 203. He could never write 0 by itself. Case 1, solved halfway. The symbol existed. The concept didn't. Historians still debate how far this placeholder traveled. Some think Greek astronomers borrowed a version of it centuries later for their own star charts. If that's true, this wasn't a dead end. It was a seed. 600 years later, 12,000 miles away, someone else hits this same wall, and they've never even heard of Babylon. Around 350 CE, deep in the jungles of Central America, the Maya were building one of the most accurate calendars in the ancient world, and they hit the exact same wall the Babylonians did. Independently, with 0 contact, an entire ocean, and thousands of unexplored miles apart. The Maya developed their own symbol for 0, often shaped like a shell. They used it constantly, tracking days, lunar cycles, stretches of time reaching back thousands of years. Some historians call the Mayan 0 the most precisely used version in the ancient world. Their entire calendar depended on it working correctly. But just like Babylon, it had a limit. The Maya never used 0 in real math, never in addition, never in equations. It marked a placeholder in dates, nothing more. One of the earliest confirmed carvings of it dates to 36 BCE on a stone monument in southern Mexico, older than most historians expected to find it. 2 civilizations, an ocean apart, landing on the same idea. Neither one knew the other existed. This is where most textbooks stop the story. But the real twist hasn't happened yet, because somewhere else, 0 is about to stop being a symbol and start being a weapon. Skip ahead again. 7th century CE, India. A mathematician named Brahmagupta is about to break math wide open. He wasn't just marking an empty column. He gave zero an identity. He called it shunya, Sanskrit for void or empty. But Brahmagupta didn't stop at naming it. He gave it rules. He was the first person on record to write formal rules for how zero behaves. A number minus itself equals zero. Zero added to any number leaves it unchanged. That sounds obvious now. In the 7th century, it was revolutionary. For the first time, zero wasn't a placeholder. It behaved like a real number. You could add to it, subtract from it, build entire equations around it. This is the moment zero stops being a trick and becomes a tool. Brahmagupta went further still. He worked out rules for positive and negative numbers too. He called positive numbers fortunes. He called negative numbers debts. Zero sat exactly between them. Neither a fortune nor a debt, just the boundary line. Brahmagupta even tried to define dividing by zero, and got it wrong. Mathematicians would spend the next 1,000 years correcting that one mistake, but the fact he was even asking shows how far zero had come. Here's where the case gets genuinely uncertain. Some historians think Brahmagupta's zero grew independently from older Indian ideas about the void. Others think the Babylonian placeholder traveled east first, through trade routes, and got reinvented. Even today, researchers haven't fully closed this part of the file. But what happens next isn't in dispute, and it's about to travel further than anyone expected. Zero doesn't stay in India. It goes on the move. Around 772 AD, an Indian scholar named Kanka travels to Baghdad. He brings a text called the Sindhind to Caliph al-Mansur's royal court. That text is built on Brahmagupta's work. Zero rides along inside it. The Caliph orders it translated into Arabic. Islamic scholars get their first real look at it. That translation becomes known as the Zij al-Sindhind. For the next 2 centuries, it's one of the most copied astronomical texts in the Islamic world. Every scholar working after it inherits Indian zero, whether they know its origin or not. A generation later, a mathematician named al-Khwarizmi picks up where that translation left off. He studies Indian arithmetic deeply and builds an entirely new system of problem solving. He calls it algebra. You know it today as algebra. He titles his masterwork Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, the compendious book on calculation by completion and balancing. Later translators shorten al-Jabr into the word we still use. Zero wasn't just useful anymore. It was foundational. Without it, algebra as we know it couldn't exist. By the 10th century, zero fully enters the Arabic numeral system. It starts taking the oval shape you'd instantly recognize today. But it still hasn't reached the one place that will resist it hardest, Europe. And when zero finally shows up there, nobody throws it a welcome party. They put it on trial. Zero doesn't reach Europe until around the 1100s. Think about that for a second. The Roman Empire rose and fell without ever using the number zero. Aqueducts, roads, an empire spanning 3 continents, built entirely without it. Roman numerals had no symbol for it at all. When zero finally arrives, an Italian mathematician named Fibonacci becomes its biggest advocate. He brings it back from his travels through North Africa. He publishes it in a book aimed at merchants and bankers. He calls the book Liber Abaci, the Book of Calculation. Inside it, he lays out Arabic numerals step by step, next to real trading problems, currency conversions, profit margins, interest rates. He isn't writing a math theory. He's writing a manual for people who move money, but not everyone was thrilled. Zero unsettled medieval European thinkers. Nothing, as a number felt almost dangerous, even theologically suspicious, in a world where math and religion were deeply tangled together. Some Italian cities actually banned Arabic numerals, including zero, from official financial records. In 1299, the city of Florence passed a law banning Arabic numerals from official ledgers entirely. Merchants had to write amounts out in words, or fall back on Roman numerals. They worried the new symbols were too easy to forge. The fear wasn't really about math. It was philosophical. If nothing can be a number, what else did we get wrong? It took centuries for zero to shake off that suspicion completely, and once it didn't just join mathematics, it rebuilt it from the ground up. Fast forward again, zero is no longer controversial, it's essential. René Descartes builds coordinate geometry around it. Every point on a graph gets measured from that single anchor. Isaac Newton and Gottfried Leibniz use it to invent calculus. They describe motion and change through quantities approaching zero. Calculus becomes the language behind physics, engineering, and eventually rocket science. Every space launch, every bridge design, every medical scan relies on it. Zero sits quietly underneath all of it, doing work nobody notices. Every computer you've ever used runs on binary code, ones and zeros, on and off, true and false. Claude Shannon proved in 1937 that logic circuits could run on nothing but true and false. That insight, dressed up as zeros and ones, still powers every microchip built today. Without this one ancient idea, there's no modern computing, no internet, no phone in your pocket. A concept 3 civilizations struggled for centuries to understand is now processed billions of times a second, inside the device in your hand, right now. So who actually solved the case first? Here's the uncomfortable truth about this investigation. There is no single answer. Babylon invented the symbol. The Maya perfected it inside their calendar. India gave it mathematical power. The Islamic world turned it into algebra. Europe, after centuries of resistance, finally let it rebuild modern science. Zero wasn't invented once, by one genius, in one flash of insight. It was solved in pieces, by people who never knew about each other's work. Which raises a question worth sitting with. If 3 civilizations independently ran into the exact same wall, how many other obvious ideas are we still missing? Concepts so basic, we don't even realize we're missing them yet. If this pulled you in, subscribe, because next time, we crack an even stranger case. How did humans first cook meat? That discovery may have changed what our ancestors ate, how they lived, and even what humans eventually became.